The problem is something like this. We have methyl lactate, which is synthesized from lactic acid using batch reactive distillation. Now, it's a reactive distillation. That means the reaction occurs as well as the distillation in the batch separation process. And the details of the reaction can be found in this paper. So they have mentioned one paper, so we have to look for this paper. Akar et al. 2016, Separation and Purification Technology. 1 kilomole per hour of methanol, which is 80 mole percent at 25 degrees centigrade, and 5 kilomole per hour of lactic acid, which is 70 mole percent at 20 degrees centigrade, both at 1 atmosphere, are fed into the batch reactive distillation. Use NRTL HOC property method, and set the process as pot. So it is not a batch distillation column, rather it is the pot distillation column of 1 meter dia and 1 meter tan length. Use 4 kilowatt jacket heating with total initial charge of 10 kilomole, where pad gas is methanol. Now we will see what pad gas is. The operating step includes changing methanol flow rate at 1 kilomole per hour at 0 ramp time and stopping the batch as soon as the lactic acid fraction goes below 0.01 in the pot. Here very clearly it has been mentioned that lactic acid will be used to synthesize methyl lactate, right? And we have 5 kilomole per hour of lactic acid with 70 mole percent at 20 degrees centigrade. So obviously when the methyl lactate is being synthesized, the amount of lactic acid will also go down. So here they say that as soon as the lactic acid fraction goes below 1%, then the separation should stop. Okay, so that is the condition that we have. Now, first thing first, let us go to this particular paper to see what the reaction is, okay, because we will need it. For that, we have to check this one. Okay, so I think this one. Is it the one? Yeah. So let us choose the view PDF. So this is the kinetic model. So here you can see lactic acid plus methanol is equal to methyl lactate and water. Okay. Esterification of lactic acid and hydrolysis of LA ester kinetic studies are very important for proper design of batch reactive operation. Several investigations have explored only the kinetics of LA ester with methanol in the past. Sands et al. Studied the kinetic behavior of LA esterification and ML hydrolysis by analyzing 3 different models: the quasi-homogeneous, the Langmuir-Hinshelwood, and the Eli-Radial models. Now, in my opinion, let us go to the original paper, that is Sands et al. 27, which will have all three different models, and we can pick and choose the best one that can be fit in our system. So it is 27, this paper. Yeah, this one. Okay. Okay. So we will see this paper. Okay. Now here you can see the general model. This one, they have given various models. One is QH model, one is LH model, and is ER model. Now this LH model is somewhat familiar to us because this is the Langmuir, Hinshelwood, Hausen, Watson model. Okay, so this is exactly what we are looking for. So here you can see we are having Langmuir, Hinshelwood model over here. Okay, so they are referring to this Langmuir, Hinshelwood, Hausen, Watson model, and we are aware of the input form of that in Aspen Plus. So let us use this particular model. Okay, and we have the general equation for all these models, that is QH model, ER model, and LH model. A common form of all of them are over here, where for LH-HW model, that is the Langmuir-Hinshelwood model, we have n is equal to 2. So here n is equal to 2 for that. Okay, so other things are given over here, that is K naught exp E by RT ALH. Now A is activity over here. Okay, so for LHHW equation we shall use this one. Okay, the third one. K naught is equal to 7.89 into 10 to the power 7. EAE is equal to 49.51. KH is equal to 8.72 into 10 to the power 6. And EH is equal to 51.35. Okay. And what about LHAM? Now these are the activity models. So here AI is equal to gamma I into xi. Okay, AI is equal to gamma I into xi. So gamma I into xi is for the mole gamma K basis. So we have to choose the mole gamma factor over here. So that will be for LH and AM. AML and AW. For that, mole gamma will be necessary. And for all adsorption terms, we have Ki into AI. All those values, it is written A, that is adsorption constants in table 1. So this is the table 1. We will get the adsorption constants. So for that, KW, KM, KML and KLH will be needed. So all information of this LH, HW will be available over here. So these things we will use. Now first thing first, let us choose the components to work with. Now let us open a new simulation. We do not want to save anything. Okay. Now we will use lactic acid. So lactic acid will work with methanol, right? So we will have methanol, lactic acid, methyl lactate and water. So we will use methanol first and then lactic acid. So this is lactic acid and then methyl lactate. So methyl lactate so this is lactic acid and this is methyl lactate and lastly water. Okay, so these are the four things that we have, and we have to use NRTL HOC property. So we will use NRTL HOC property Okay, now go to the simulation. Now let us first put the reactions over here, okay, because this appears to be very cryptic. So let us first fix the reaction. Now let us choose a new reaction which is general and we will use the LHHW type, which is reversible. Let us give a name reaction, and this is lactic acid and methanol that produces methyl lactate and water. Okay, so this we have. Go to kinetics. Okay, now in the kinetics, this particular equation we have to give a proper format, and that proper format will be something like this. This we will take common, then we will have k into exponential e by RT, and then there will be a of LH into a of M minus there will be something into a of ML, a of W by 1 plus KAI square. Why it is square? Because for LH model or LHHW model, we have n is equal to 2. So this is 2. So that is how we can set it with the functionality that we have over here. Okay, so this is the kinetic factor. So this is the entire kinetic factor that we have into the driving force. Okay, now in order to do that, first we have to check out the kinetic factor from here. So your Ke naught is equal to 7.89 E7 and KH naught is equal to 8.72 E6. Okay, now if we take this one from this one common, then basically what we have over here is KH by KE into e to the power minus EH by e to the power minus EA naught. And that's exactly what we are going to calculate. For that, we will have exponential of 51.35 by exponential of 49.51 this is negative. Okay, because exponential of RT will get cancelled anyway, and then multiplied by KH naught by KE naught. So it is 0.0176. That means this one is basically KE naught exponential of E A naught by RT A of LH AM minus 0.0176 into AML AW by 1 plus KIAI square. Okay, so that's what it means. So we will simply add in these values over here. Okay, so for that we write them one by one. So the pre-exponential factor is, this one is K, which is 7.89 E7, and then this one is 49.51 kilojoule per mole, 49.51 kilojoule per mole, and instead of molarity we have to use mole gamma. We have already seen why we are using mole gamma, because it is xi gamma I. Okay, so this is xi gamma I. For this reason we will use mole gamma. and then specify the rate constant and concentration exponent. Now here for the forward reaction, it is lactic acid methanol. It is exponent 1 because we have seen it over here. So this is exponent 1, this is exponent 1, this also is exponent 1, this is exponent 1, but for forward reaction there is nothing, it is 1. But for backward reaction we have 0.0176, okay, for this one. So for 1, here we have to give the exponential term. For that we have to provide 0 because here the coefficient for the driving force constant, we have to give a value to A, for which the whole term, that is ln of constant 1 is equal to A plus B by T into C ln T plus D into T. Okay, so basically what it says that ln K has to be A plus B by T plus C into ln T plus D into T. So this is the equation. So we have to provide a value over here. Okay, some value we have to provide over here, for which your K becomes 1. Okay, because if B is equal to 0, C is equal to 0, D is equal to 0, then if K is equal to 1, then ln 1 is equal to 0, right? So for that we have to provide 0 over here. Once we put 0 over here, that means K is equal to 1. So forward case, K is equal to 1. And for backward case, the reverse case, this will be 1 and this will be 1. And we have to provide some value to A, and here it is 0.0176. So we have to put the value 0.0176. So we have to give a certain value so that 0.0176 comes. So it will be log of 0.0176. Yeah, so it is minus 4.04. Okay, now let us go to the adsorption. Right, so here adsorption term is equal to term 1, term 2, term 3, term 4 and term 5. So basically what you have term 1 is equal to 1, term 2 will be K of methanol into A methanol, term 3 will be K of lactic acid into A of lactic acid, term 4 will be K of methyl lactate into A of methyl lactate, and term 5 will be K of water and A of water, and the whole thing squared term over here. So adsorption expression exponent will be square over here, it is 2, and all other terms we have to write one by one. So first thing first, let us write it as 2 because it is squared term, so it is something to the power square, and then we will write term 1, term 2, term 3, term 4, and term 5. Okay. Now first, term 1, we'll use 0. Once we put 0, then it will be k1 is equal to 1. So first term is 1. Okay. So this will be 0, this will be 0, okay. Then term 2, methanol will be 1. Okay. So methanol is 1, all other thing will be 0. So for methanol, you know the term is 5.0071. So you have A is equal to 5.7126, 5.0071, 0.6211, 5648 log of A. Yeah. So we have to put these values. So this is 1.6109. 1.6109. So it is 5.0071. Term 3 will be of lactic acid. So this will be 0, this will be 1, this will be 0, and this will be 0. Okay. So number 3, for 0.5648. 0.5648. So this one. 0.5648. Then term 4 will be methyl lactate. So this is 0, this is 0, this is 1, and this is 0. So term number 4, methyl lactate, 6211. So this is 6211. We will choose this one. So 6211. Okay. And the final term will be of water. So this will be 0, this will be 0, this is 0, and this is 1. and for water it is 5.7126. So this one. .7126. Okay, so all terms are there. So it is K1 is equal to 1, K2 into methanol, K3 into lactic acid, K4 into methyl lactate, K5 into water to the power whole square. Okay, so that's how we have given the adsorption terms. So that's how our reaction is specified. So it took us a lot of time, but painstakingly we have created a reaction for the whole system. So our test run is saved.